Good evening, sir. This is Kunal Jaiswal, 19BCE1321, and I'm going to do my digital assignment 2 on the topic Apriori algorithm based association rule mining in simulator rapid miner studio. So, so this algorithm is basically used to create association rules for finding the frequent item set. So as to proceed with, we will see on the iris data set over here. I have imported the iris data set. Now we will use FP growth operator. Now we will use FB FP sorry FP growth asso- association operator in order to find the frequent item sets. But the problem is that we can connect the data center to clean the FP group, because if growth works on attribute which are unable to by operator. So FP growth work on the data set which is binomial in value. So So first, what we need is to convert data into nominal, and then by doing so, for doing so, we will discretize thing like operator, discretize by frequency. We will use the frequency operator in order to convert data into nominal attributes, and further, we will use we will use like nominal to binomial. Further, we will use like nominal to binomial uh, operator in order to convert the nominal operator into binomial operator. Then further, recurrently nominal to binomial operator to FP growth. So connecting, uh, after connecting like this, uh, so after connecting like this, the rows will be the frequent items, and that output will be giving the association rule operator. So we will connect this with uh, sorry. So since we have connected all this, so FP growth will be recurrent item sets, and that output will be giving to the create association rule operator. And here it is. It, yes, here it is. Create association rules, and I'll connect it like here with this one. Let me rearrange this in order to, yes, let's verify. So so after connecting this, we do the disconnection also, and both connections are set now, and we will then run this process, and after that we will get like frequent item sets, FP growth, and association rules. So this is our association rules, and this is our frequent item sets. So we will get like association rule over here, and we will get like data, and we will get some graphs. This is our rule. Like if I get like for petal length, this is our petal length width, sepal length in centimeter, and species. So these are some graphs, and these are the description like petal length. Uh, and I forgot to mention that these are plotted in order of like attributes and the rules associated with it, and we have description, and there is association rule that is it is and we have like a description in this. We have association rule that is if petal length in centimeter exists, then petal width of centimeter and sepal length of centimeter will exist in the form of item set, and this confidence is 82%. And like species, if species is Aris setosa, then sepal width will be must be there. Similarly, we have plenty of the things like if iris is virginica, is petal length centimeter, and species is iris virginica, then there will be present petal width centimeter. Their confidence interval is 100%. So it means they all do exist. So we have here we have in data confidence, lift, conviction, PS, gain, Laplace, and it's like premises and conclusion is like if petal width is centimeter is present, then there is high probability that petal length and sepal length will be the will also be the present in order to predict or um, in order to uh, predict our target variable. So if the if the species is Iris virginica, then it has like high probability that petal length centimeter and sepal length will be present there, and our support value is for the petal width centimeter and is 4.413, and what support and confidence is like support is an like indication of how frequently the item appear in the database, and the confidence indicates the number of times uh, the number of times the statements if statements have been found to be true. The frequent if patterns are mined using operator like FP growth operator. The create association rule operator take these frequent item sets and generates association rule. Such information can be used as the basis for decisions about marketing activities such as promotional pricing or product placements. Now, and its support value is also given here, like 0.413, 0.861. Support means how frequently the item appears in our data set, and confidence level shows that how much true these statements have been found to. So this was our practical for running this association rule algorithm, and these are output. And so what I did is I retrieved the Iris dataset connected with discretized data operator, then connected to nominal to binomial operator, then connect it to FP growth operator, and then we will create it to connect it to create association rule or to create association rule to give us the outputs. And I have, I have discretized the operator to in order to convert the attributes into nominal. First into nominal and then to binomial using a nominal to binomial, because FP growth works only on nominal attributes, and the output of the FP through growth will be the frequent item sets, and that output key we have to keep it to create association rule. After doing it, if we run it, we will get the like needed result. Association rules and frequent item sets. Like for one is petal, if size item set size is one, it is petal set, petal length, petal width, sepal length, sepal width, set species, iris setosa, like all the mm, attributes of polynomial data type we will get here. So we have support value of zero point 0.5, like 50%, 48%, 46% here, 33%. Now moving on to the uh, now moving on, we will like do like for k is equals to 2, we have like petal and centimeter petal width, and support values 43%, 46%, and so on. For k is equals to 3, we have petal and centimeter petal width and sepal length. Of course, we got like support of 41%, which is also a high value. So that's all with my algorithm. Thank you, sir.